So we'll quickly learn about PN junction. So before that, we'll see how many types of semiconductors are there. Semiconductors. So how many types of semiconductors are there? There are two types. First is intrinsic and another is extrinsic. So in extrinsic, you have P type and N type. Let us quickly see what are intrinsic semiconductors. Intrinsic semiconductors. I'm writing shortcut. So intrinsic semiconductor is nothing but it is pure semiconductor material. It's pure semiconductor material. Okay. Has lower conductivity. Has lower conductivity. It has equal number of free electrons. Equal number of electrons and as well as holes. Okay. So in P type, majority charge carriers are holes, and in N type, majority charge carriers are electrons. I hope you all know this. Next is intrinsic semiconductor. Intrinsic semiconductor. So what is intrinsic semiconductor? So intrinsic semiconductor is nothing but it has impurities. Okay. Impurities with pure semiconductor. Impurities with pure semiconductor. Next, it has high conductivity. That would be opposite of intrinsic. Okay. So high conductivity. Next, and what are the examples for extrinsic? Examples are N type and P type, right? And example for intrinsic would be silicon and germanium. So this is P type and N type. I hope this is clear. Now we'll quickly move to what is PN junction first. Okay, so let us see what is N type semiconductor. N type semiconductor. And next is what is P type semiconductor. Okay, so in N type, N type, we add what will you add? We add pentavalent impurities. Pentavalent impurities means 5 valence electrons will be there. Pentavalent impurities. Okay, next in P type, we add trivalent impurity. Add trivalent impurity. Okay, so in N-type semiconductor, one free electron is added. One free electron is added. Next, added when with every impurity. With okay. So it is also known as donor impurity. Is known as donor impurity. In N-type, majority charge carriers are electrons. Here, majority charge carriers are charge carriers are holes. And there it is, electrons. No? Now, this is very important. How is PN junction formed? So, okay, this may be asked in the exam. So, if it is asked, you have to write it like this. Okay. So, this is the main answer that starts. So, it's PN junction. How is this junction formed? N junction, right? Diode. How is it formed? So, as I told you, P type has what? P type has trivalent impurity, no? Trivalent impurity. So, which leads to holes as majority carrier. Okay. Next is N type has pentavalent impurity. It has pentavalent, which leads to what? Electrons. Okay. Now, what will happen after diffusion? After diffusion at p-n junction, after diffusion at p-n junction, p-type materials and electrons of n-type recombine, and n-type materials, n-type, this is n. So n-type materials, poles of p-type recombine. So electrons and holes both are meeting at p-n junction. Okay, so that is why it is called as p-n junction. So for example, this is p-type and this is n-type. In p-type, what you'll have? You'll have electron holes, no? Whereas in n-type, you'll have electrons, no? So at p-n junction, both will combine. Plus minus, plus minus, plus minus. Both will combine. So what will happen? So there is a region that is formed. There is nothing but called as p-n junction. So this is your anode and this is your cathode. So depletion region, it will not allow any flow of current. You can write the region of ions. The region of ions is called this one, that is p-n junction.